Hello, students. I'd like to talk about a different equation that we did not have a chance to go over in our class on Wednesday. And it's problem 25 from our web work. It says the square root of, oh, and by the way, this is P1, right? This is our P1 module, solving equations. And so our P1 module in web work has problem 25, which says the square root of the quantity 10 minus x plus x equals 8. And first we're asked to identify the type of equation this is, and this is clearly a radical equation, a radical. And what makes it a radical equation is one fact, which is it has a radical symbol in it, a square root in it. Other radicals would be cubed roots or fourth roots, okay? So it has a radical in it. But more importantly, within the radical is where the variable is housed. So if you have equations where inside you have variables or some form of variables, right, then that makes this a radical equation. And so we can see by the placement of the x within this radical sign, we have a radical equation. So what does that mean for us? Well, it sets our goal up for how we're going to proceed to solve this. So the placement of the x inside a radical is troublesome if we're trying to figure out what x is. And so our very first goal, the first thing we want to accomplish, is to get the x, so to speak, out of the radical. So we want to remove the x from within the radical and get it out. Okay, so that becomes our focus of the process we're going to proceed to do. One other thing we're asked to do in class is to say, okay, well, how does this relate to what we're going to learn in the future? Why even worry about solving radical equations? Well, probably the most apparent and the most frequent use of radicals comes with this idea here, where you have a right triangle and three sides. And there's a famous theorem or formula that goes with right triangles, and I think everybody knows this one, right? A squared plus b squared equals c squared, or the length of one leg squared plus the length of the other leg squared equals the hypotenuse squared. Also known as, what do we call that? The Pythagorean theorem. Pythagorean theorems are all filled with radicals, right? Because if I want to isolate any of the single sides, let's just say I want to get a by itself within this formula, right? My first step would be to subtract b squared, but then my next step is to get a by itself, and we do that by taking a square root of both sides, right? And there's a plus or minus, but when there's a radical involved, we don't have to worry about that negative side length. So right away we see radicals are involved. Where else do we see radicals? Well, it's in the concept of distance, right? Which relates directly back to a Pythagorean formula. Think about like how a virus or anything spreads, nuclear radioactivity, it spreads in a circular fashion, right? And so let's say we wanted to find the distance between an epicenter or a center and a position on the on the outside of that circle there, their circumference, along the circumference somewhere. That distance right there is a physical distance, and I mean, if you think even more about it, it actually serves as a hypotenuse of a right triangle, doesn't it? And so inherently it has a square root. And so I'm just going to throw something else up there to bring some more connections in. You might have seen way back when you talked about distance between 2 points in space, we had this formula for distance, which is y2 minus y1. Whoops, sorry, undo that. X2 minus x1 squared plus y2 minus y1 squared, right? This might look familiar to you. That's our distance formula. But again, what do we have out here? We have a square root. And so we talk a lot about radicals and use radicals, both in calculus and in our STEM applications. All right, so that's just a few places. That being said, let's get back to our radical equation that we're trying to solve and remind ourselves of our goal, right? Our goal is we want to get the x out of the radical. And how are we going to do that? Well, let's see. Let's start by isolating that radical, since that's where our focus lies. And to isolate that radical, that means I'm going to want to move this term x from the left to the right side of the equation. So I'm going to use my additive property of equality, where I'm actually adding a negative x to both sides, or if you like, subtracting x from both sides. And so that allows us to result in the statement that the square root of 10 minus x equals 8 minus x. And more importantly, it sets us up to work towards our goal, which is get the x out of a radical. Now, at this point, you might be saying, oh yeah, I remember doing this. To get an x out of a radical, I have to perform an inverse operation of the square root, which is I want to square both sides, right? So the opposite or inverse operation of taking a square root is squaring something. And so I am going to square both sides of my equation to keep everything balanced. And doing so gives me the following. On the left side, notice I have a square root of 10 minus x squared, which is the square root of 10 minus x times the square root of 10 minus x. Anything times itself within square roots just becomes itself. Or, if you like, the square root and the square cancel each other as inverse operations, resulting in just 10 minus x on the left. And on the right, what's happening here? Ooh, be really careful, right? We have a binomial, two terms, right, designated by the minus. So 8 minus x, two terms, binomial, square. And when you have a binomial square, you have to be real careful. What is 8 minus x to the second power? Well, that's 8 minus x times 8 minus x. And if I want to simplify and expand that, I need to use the process of what some people refer to as FOIL, first, outer, inner, last, or more formally, a distributive property, where I have to distribute each term in the first binomial factor to every term in the second binomial factor. So I'm applying my distributive property. Doing so results in the following: 8 times 8, which is 64, and then 8 times negative x, which is negative 8x, and negative x times 8, which is negative 8x, negative x times negative x, which is positive x squared. Now, some people jump right to the next level, which is they, in their head, combine these two like terms, right? We talked about that in class. In order for you to add things together, they have to be quote unquote like terms, which means they have to have the same variables expression attached to that term. And so that gives us 64 minus 16x plus x squared. Okay, stop and take a breather. Pat yourself on the back. We have gone through a big process and we are heading towards the finish line. We no longer have a radical equation. We've taken the x out of that radical, and we've resulted in a statement which actually looks very similar and in fact is a polynomial equation now, right? We have a polynomial equation. More specifically, we actually have a quadratic equation, and that's because we see that the highest power is the power 2. Now, recalling from class, there's two ways that we approach quadratic equations, or polynomial equations too, the first way at least. And that is, first we try and factor. If we can factor, we'll factor that polynomial equation. And the second way is to use quadratic formula. Quadratic formula always works, but sometimes it gets messy, so we choose to factor if we can. But if we're going to factor, there's something key we have to remember. When we factor, we're going to wind up with a product. We have to make sure that that product is set equal to 0. Do you remember that from class? We talked about something called the zero factor property. And the zero factor property tells us that in order to solve a quadratic equation, we want to make sure that our product is set equal to 0. And in fact, the very first thing we do is set everything equal to 0, and then we factor. And why does that work again? Just to remember, why are we doing what we're doing? Because when you have a product of two numbers set equal to 0, the only way that can happen is if the first factor is 0 or the second factor is 0. And therefore, that thought bubble right there moves us into the next level of solving on this quadratic equation. We want to aim for a 0 on the right side and then factoring. Okay, so what do I note? Well, I note that my x squared is positive. And that means to me, I want to save myself some effort. When I go to put all these terms on one side and 0 on the other, I think I want to keep my x squared being positive. Therefore, that means I want to move the two terms that are on the left side and bring them over to the right side. I'm going to use that additive property or addition property of equality and add a negative 10 and a positive x so that on the left side, those two terms cancel, resulting in that 0 that I'm trying to get. And on the right side, notice I lined up my columns. 64 minus 10 is 54. Negative 16 plus x or plus 1x is negative 15x. And so I have 54 minus 15x plus x squared equal to 0. And just to help my brain out, I think I want to put all of those terms or that polynomial on the left and 0 on the right. Okay, now we factor. And we're getting good at factoring, hopefully. We want to factor, means find a product of two binomials in this case that make the trinomial. We know our first terms are going to be x each to make x squared at the front end. And now we're trying to get 54 at the back end. So we're looking for, thinking in our thought bubble here, we're looking for two numbers that multiply to 54, but then combine or combine to give us negative 15. Think a moment. Two numbers that multiply to give me 54. Well, 9 and 6 come to mind immediately, right? I want them to be multiplied together to get me a positive number, which means they have to be the same sign, but I want them to add to give me negative. Oops, sorry about that. So that means they both have to be negative, right? Negative 6 times negative 9 is positive 54. Negative 9 plus negative 6 is that negative 15 that I'm looking for. And magically, those are our magic numbers. And they result in our factors. So x squared minus 15x plus 54 is factored as x minus 9 times x minus 6. Okay, we are in the home stretch now. Using or applying the zero factor property, that means each of these factors, one of them has to be 0 to make this statement true. And so we're going to set x minus 9 equal to 0 or x minus 6 equal to 0. And that means that x has to either be the value 9 or x has to be the value 6. Okay. Yeah, so we're like, okay, we did it, right? We finished solving this radical equation. We wound up with two solutions. We plug them into WebWork and it gives us a big X. It's wrong. Okay, so what is going on? Well, if you watch the video with logarithmic equations, you'll remember that I specifically stated that when you have a logarithmic equation, a rational equation, which is what we have, right? A radical equation, my bad, which is what we have, or a rational equation, you always want to be careful to check your solutions because sometimes you get extraneous roots that occur in our algebraic process of solving. So we are going to check our first value, x equals 9. Put it way back into the original equation. So I want to write down my original equation again just so I remember. It was that the square root of 10 minus x plus x equals 8. And we're going to take x equals 9 and plug it in. And that's going to give us 10 minus 9 plus 9 equals 8. 10 minus 9 gets evaluated first. Giving me the square root of 1. This gives us 1 plus 9 is 8, and oh, hello, this is not true. This is definitely not true, right? 1 plus 9 is not 8. It's close, negative 1 plus 9, but this is a case in point where we have an answer which, although algebraically we come up with it as being a solution, it is not a solution to our original equation. This is called an extraneous solution. It's an extra solution that does not work. And so we cannot include it in our final answer. It doesn't work. So it doesn't make sense, right? So instead, let's check that second one, and hopefully this is not another extraneous solution. So we'll put 6 in for x and solve this equation. Again, do what's underneath our radical first. 10 minus 6 is 4. Square root of 4 is 2. 2 plus 6 is 8. That is looking much nicer. I think that is an official solution. And so we would say that there is a single solution to this radical equation, and that radical equation solution being x equals 6 only. All right. Well, I hope that this process made sense. I hope you learned something with this, or it rejuvenated some of those old mathematical connections that you have. The key I want you to take is make sure when you have a radical equation to isolate that radical if you can, square both sides, proceed to solve, and always, always, always check your final answers. Good luck. And we have one more equation I'm going to talk about, which is our rational equation.